All right, so reviewing lecture test number 3. I can tell you that this test in particular has a lot of repeats showing up for the final. There's really nothing more. Not that this stuff is, well, I guess maybe it is a little more important than some of the other stuff we talk about, but it's just sort of the, the meat and potatoes of what you would come to expect in a Geology 101 class. It comes through in test number 3. So questions you missed here you might want to pay particular attention to so you don't get them wrong again in, say, a month. We got our series of weathering and erosion questions here to get us started. So the process that breaks down material, all right, breaking down is indeed weathering, yeah. And, and even these are repeats, so to speak, from the rock cycle, which separated itself out onto the previous test, if I'm not mistaken. But we really want to make sure you guys get down the difference between weathering and erosion. So if weathering was breaking down, erosion was the transportation, okay? Transportation of these materials. And I'm not sure if it shows up as a question here in a moment or not, but just in case, we traditionally use the rest of these words here. We're going to see that deposition is the putting down of those materials. And sediment is, well, what we've been talking about this whole time. Weathering produces sediment. Erosion transports sediment. Deposition is the putting down of said sediment. So one of those question cycles where I use everything up, and lo and behold, I guess it is right here. I got a huge glare, so I can't quite see. So geologists use the term blank when these materials have stopped being moved. We call that deposition. And the stuff we've been talking about this whole time, as I just said, is sediment. All right, now we're going to go to the other end of the spectrum, and we want to take all those sediments, and we want to turn them into rock. Which word fits that? Lithification. Beautiful. Beautiful. Come on, next page. Speaking of sediments, what can they be made out of? Pretty much anything, okay? So organic material, sure. Inorganic material, definitely. So both A and B in that case. So boulder, cobble, pebble, sand, silt, clay. What did I ask you for this time? Okay, I did ask you for largest to smallest. Sometimes, as I said, I mix it up and say smallest to largest. Please, on the final, should you see this question, make sure I didn't reverse it and ask you for small to large, because small to large is in here as well, all right, for the very occasion that I do sometimes switch the verbiage around. Now we're looking at our 3 types of sedimentary rocks. Remember, we had clastic, chemical, and organic coming off the rock test. This hopefully wasn't too difficult for you guys. Bits and pieces of previously existing rocks and minerals. We call those clastics. Speaking of clastics, which of these is not a clastic? Well, sandstone is made up of little bits of rock that are sand-sized. Conglomerate's made up of what? Pebbles, sand, silts, and clays. And shale's made up of silts and clays. Yeah, these are all sedimentary rocks. Bits and pieces of previously living materials. That there is organic. Crystallizing from solution. I had a handful because I had to go back through and grade your extra credit questions by hand. Every so often I'd stop and peek at a few answers. Handful of you missed this question. And I'm not sure why. This is, out of all of them, probably the chemical sedimentary rocks are the ones we talked about the most. Crystallizing out of solution is what we mean when we say, crystals grow in water. And I'm worried that it's the chemistry terms that maybe threw you off course there. I'm not sure what happened. But yes, they do indeed do that. So a lot of you picked answer D is what I'm going for here. And in order for that to happen, that's also sort of a nudge that it's a real thing. What do we have to do? We have to saturate or oversaturate. All right, we talked a lot about oversaturation. That wasn't an option here, so the closest thing you had was saturation. And, you know, if you were confused, again, that's one of the reasons I encourage you guys to take the test here so you could come up and say, you know, ask me a question. So what kind of rocks do this? Well, your chemical sedimentary rocks, obviously. Halite is a great example of that. Limestone is a great example of that. And gypsum is another one that's a great example. It's not on here, though. So gypsum grows in the same manner. Quartzite, however, is a metamorphic rock. I didn't give you an answer for all three of those anyhow, so hopefully you sorted through that one. Oh, I did give you a none of the above, though. All right, the classed size ones. I don't mean these to be confusing, and perhaps the overthinkers out there are thinking that, okay, there's no way on God's green earth that sandstone is only going to be composed of sand-sized grains. There's going to be, just because of pure dumb luck, happenstance, whatever you want to say, you know what, there might be a little bit of clay and silt in there. Maybe I should write the words generally speaking or typically, or I don't know what, but certainly I wanted you to pick what answer here. Sandstone is made of sand. Thank you. Yeah. But a lot of people miss this one too. So I have to think that it's overthinking. Mudstone is made from mud, which is silts and clays, right? Is there going to be a grain of sand in there? Maybe an odd pebble? Sure. It's Mother Nature. She does whatever the hell she wants to, right? We just make tables that try and explain what Mother Nature's doing. But generally speaking, mudstone is made of stuff that makes mud, which is silts and clays. And then there should be one about conglomerate coming up next, where you were supposed to pick all of the above finally. And again, the thing about conglomerate is it's really relative. You could have a conglomerate, I suppose, that's made out of boulders. Okay? It's all a matter of scale. You know, we just didn't get as far in here as talking and worrying about boulders. But you certainly could have something of that scale. And I'm sure they've got a special name for that rock, too. All right, now a little bit of environmental interpretation. Okay, this wasn't out of the blue. We did spend some time talking about the fact that, actually we spent a decent amount of time talking about the fact that sedimentary rocks are very directly products of an environment that you could fairly easily interpret as well. So when we see a rock made out of seashells and crushed up bits of rock, we are quite hopefully possibly to assume that this area was somewhere where there's seashells and rocks and other sand grains, i.e. a beach. Okay. In fact, in lab, I told you guys that was my favorite rock because it is a hunk of beach. Bituminous coal. You've been hearing this since you were 5 years old. Okay. Coal is old swamp or old plant material. So when you see a vein of coal, no matter how hard it is to believe or to process or whatever word you want to use, before that coal was coal, right there was a swampy, marshy area. Okay? That's the kind of stuff that we're putting together in our brains at this point. And limestone, even all the way in here in New York State or in Ohio where I grew up, if there's limestone there, that means there was an ocean there. Okay? So, or at least salt water. But generally speaking, easy enough to say, an ocean. And there was, at least as far as we can tell, a giant inland sea basically between the Rockies and the Appalachians. Came in through the Gulf of Mexico, flooded that whole area out for a very long time. Sea level was a lot higher then. Al Gore, Bill Nye, not completely nuts. It has happened. You guys probably don't even know who Al Gore is anymore. He did try running for president in 2000. It was in what? Futurama. Ah, well, yes, Futurama makes fun of everybody. But yeah, no, and he, yeah, there was a lot of things. When I was growing up, he and his wife Tipper led a group called the PMRC, Parents Music Resource Center. They were out there burning rock and roll albums because they were too vulgar, which is why I really, really had trouble voting for Al. But he was the lesser of two evils at the time. So, but I never truly trusted him because of that. Freedom of speech. All right. Anywho, no politics. A rock formation name is typically based on what? Well, hope. Beautiful. Thank you. Yeah. Hopefully, when it's being helpful, it tells us what kind of rock it is and maybe where we could find the best example of it. We know that sometimes we've got to not say, shale, they'll just say formation. Okay, and that was a tip for you guys. Hopefully that's the next question. Nope, it's not a question on here. The next question, but when it just says, let's say it says Utica formation, we know that's a tip to us that there's more than one rock type in that little section there. But otherwise, if we said Utica shale, we'd know, hey, that it's a shale, and hey, there's a great example of it in Utica. All right, more geotime stuff. Long periods of time that are missing from the rock record are called unconformities. Good, 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 good. How do you get an unconformity? Well, obviously an animal chews up all that rock, right? So it's all gone. No, not that one. A shift to an erosional environment. Erosion, it could essentially be like an eraser, okay? It removes all the rock that's there. Also, you could just be a non-depositional environment right out here right now, looking out the window of the classroom. Not really what we would consider a depositional environment. And all of those, should we all of a sudden turn into a depositional environment, say a glacier perks itself a couple miles north and starts spewing out all kinds of rock and over Utica again, well, you're going to have a gap in the rock record of several million years. That's an unconformity. And in between those two layers of rock, the old one and the new one, they would call that a contact. Now, a bed is the layer of rock. Bed is the layer of rock. The contact is that sort of dashed line in between the two layers. Yeah. All right, now some trace fossil-y kind of stuff. Oh, well, I just gave you the answer. Gnaw mark on a bunny leg bone would be called a trace fossil. The next question asks you about the bunny leg bone itself. That's a fossil. It became evident during the extra credit question that you guys weren't necessarily sure what the difference was, or you simply memorized the definition but couldn't really apply it. So bits or pieces of an organism that are found preserved in the rock record are a fossil. All right? They are the critter itself, whether it's preserved, altered, or unaltered, replaced, whatever word you want to use, okay? That is a fossil. If we see evidence of a critter, that's the trace fossil. So footprints, so on and so forth. Or in this case, we didn't actually see the wolf that perhaps was the one chewing on the bunny, right? But we see these teeth marks on the bunny leg bone. We see evidence of predation. So that is definitely application level, don't get me wrong. It's a little higher up Bloom's taxonomy than I usually ask you guys to go. But that is a trace fossil, okay? And it really isn't that bad because I sat up here and babbled to you about the snail chewing a hole in the back of the other snail. So I kind of just twirled off of that with another terrestrial scenario. All right, anywho. Slanted or crossed beds, and I probably should say of sand. I'll fix that. Actually, that question's very old. That's the first time it's ever occurred to me that I probably should say of sand. But hardly anyone misses this one usually. Get a couple people here and there. Was evidence of a desert environment. All are part of a plant or animal. We just talked about this. That's a fossil. All right, ripple marks. Symmetrical versus asymmetrical. Are they on the same screen for you guys here? Only if we do it right there. All right. Symmetrical is formed by back and forth constant water action, always equal. And it might be hard to imagine if you've sat there and stared at the waves going back and forth that it is more or less equal pressure. Maybe until you felt that undertow pulling at you. It's strong going back out. The waves look all powerful and everything when they crash down on the shore, but the force that pulls them back out is just as strong. So that constant back and forth does leave marks, but they're very even. They're symmetrical. So symmetrical equals waves. Asymmetrical, not symmetrical, is one directional flow of water. That is a stream. Okay. All right, more thinking. I think you guys did pretty good on this one, though. Series of rocks that starts with sandstone, then has a layer of shale, then igneous rock, then sandstone again. Which statement best describes their age relations? This is possibly the hardest question. All right, but again, you guys, for overall, I think you did pretty good on this one. It's hard to get stats when it's online like this. You'd think it'd be easier to get stats, but so what's what throws the monkey wrench in here is I don't tell you what kind of igneous rock it is. Because think about it, if it was a lava flow, then it would definitely be chronological. You got sediment, 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 lava flow, sediment, sediment, sediment. They're in order, uniformitarian, original horizontality. No, superposition. There we go. That's the one I wanted. Superposition applies. Okay? They're in the order that they were. However, if that's an igneous intrusion, any one of the layers of sediment above that intrusion, any or all of them could have come at some point. You don't know when. All right? Obviously, for it to intrude, you had to have at least one layer there, but it could have went sediment, 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 then intrusion, then sediment above that, like two notches above it kind of thing. It's hard to explain without pictures, but the point is C. Okay? You need to know whether or not it was an intrusive or an extrusive igneous rock. All right, now all of our principles. Undisturbed section of rocks, oldest at the bottom and the youngest at the top. That is indeed the word I was just struggling to pull out of my brain. Superposition. Environment extends outwards in all directions until it blends into another direction, another environment. That is lateral continuity. An aquatic environment, sediments are deposited in flat layers. That there is original horizontality. And an igneous intrusion must be younger than the rock it has intruded into. That would be cross-cutting. Cross-cutting. Somehow we still have 5 more pages. Well, 4 at any rate. All right, going into solution. Weathering or erosion or what? All right. This is an example of chemical weathering, but it is also what we call dissolving. All right. We took a lot of time to approach it from that direction because everyone knows what the word dissolve means. So we wanted to take the time to connect the word dissolving to going into solution, and hopefully that worked for you. Coming out of solution. Strangely not undissolving, right? Or resolving. But it is called precipitating. So in other words, it is no longer dissolved. This is where we go into that saturation, or again, at least briefly oversaturated. Spits out the material, and you get a deposit. Frost wedging, based on the idea that water expands when it freezes. That is physical movement, not chemical stuff. So we're looking at physical weathering. It is not what glaciers do. Glaciers do a variety of things, but very little of it is based on the fact that the water expands and contracts as it freezes and or thaws. So this time we just have one answer there. Now we're back to multiple answers again, I think. Abrasion is physical weathering. Remember, rock versus rock breakdown. All right, and that is how we get a rock smoothed out, whether it's rolling back and forth in the waves, rolling around in a stream bed, or heck, even blowing around in a desert. Little by little, the sharp, thin, pointy bits of the rocks break off from hitting other rocks, and you're left with a smooth, round rock in the end. And yes, the agents certainly can work together. Physical weathering and chemical weathering. We didn't exactly talk about this in class, and I think the next question says that exact same thing. There was one duplicate question, if I remember correctly. Just think about any time you want to try and dissolve something. Generally speaking, what do you end up doing? You end up breaking it up into smaller pieces, right? With very few exceptions out there. And it's all about surface area, really. Or the idea that it's easier for smaller pieces to dissolve than one big, large piece, which again is kind of surface area. So at any rate, you're increasing the amount of available surface that is available for dissolving or going into solution, so that enhances it. Generally speaking, physical can enhance chemical, and vice versa is true as well. If you leave something out there, think of a rusty car, okay? If it's out there, which is chemical weathering, right? It is much more easy to fall apart if you whack it with your fist, let alone, drive into another car or a tree, God forbid. The fact that there's rust present will make it much less durable. So these guys certainly work together. So the agents of weathering, that is wind, water, ice, and gravity. We see gravity, we see ice, we see wind. We don't see water, but 3 out of 4 ain't bad, so we'll take it. Here's that repeat question. Okay, hopefully you answered the same way twice, or again, if you were confused, and I think somebody did come up and ask me, that's how I found out there was a repeat in there. A great argument for taking the test here. You always can email me again if you are at home taking the test. Generally speaking, I notice emails when they pop right in, as long as I'm not, lecturing or something, which I wouldn't be while I'm sitting here watching you guys take a test. So even if you are at home, you could send me a quick email, as long as you promise not to Google anything while you're on your phone. All right, a couple metamorphic rock questions. We promised you there'd be a few, and there were just a few. Only to extremely high temperatures. All right, so that is foliated versus non-foliated. Non-foliated is temperature only. Foliated, remember, you need that pressure to get the things lined up. And arguably, yes, we did talk about that more in lab than we did in lecture, but we did give you a heads up on that one. Extremely high pressures and temperatures that there is, as we said just now, foliated. Another application level question. Goodness gracious. All right, thinking back to our conversation about igneous intrusions, if some magma intrudes into some bedrock, the bedrock would undergo what we call contact metamorphism and change into a new rock. So, if some magma intrudes into some limestone, what might we find around the intrusion? So we're basically asking you, what does limestone metamorphose into? And that answer is what, you guys? Marble. Beautiful. Beautiful. How would we get quartzite? Just to run you back through all this wonderful stuff. Sandstone. Yep. How about slate? There's an easy one. Shale. Good. Anthracite comes from bituminous. Because again, on the final, I could very easily change any one of these, answers just a little bit here. The question more or less remains the same. We're just changing the rock. And as we had only this token few of metamorphic questions, there's a good chance that they'll make the cut. I'm not sure how these questions got separated, but we're back to talking about geologic time for a little bit. Philosophy that implies that the processes occurring today occurred in the past at similar rates. What do we got there? Similar rates is uniformitarianism. Rapid changes in the environment are possible or responsible for the Earth as we know it. That's the catastrophism, yep. And the real true one. Now, the one that sees both sides of the argument and is quite possibly, really, as I'm hinting strongly at you, really what's going on. We're looking at actualism, okay? We can't ignore the fact that an asteroid smashing into us doesn't change stuff. By all means, it does. But also, we can't ignore the slow and steady wins the race argument either. So, it's a little bit of everything, as always. All right, now we got to apply all that. If the same processes that occurred today occurred in the past at similar rates, so on and so forth, what does that mean to get, let's say, something like the Grand Canyon? It means that we need a really long time for all this to happen. Okay, this is an argument again for what they call deep time, or the fact that the Earth is very, 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 very old. Very, very. All right, geologic time that looks comparatively, not numerically. We're talking about relative dating. Not dating relatives, but relative dating. All right, using numbers. I threw in some sort of fake words here, like chrono sorting. That maybe sounds appropriate there. But no, absolute. Absolute. When dating a sedimentary rock, you will receive a variety of dates, and this could be attributed to which of the following principles? Any thoughts? Inclusions. Yeah, the fact that it is made up of many, many, many different pieces, parts. We gave you the Chicken McNugget example here, okay? It's really hard to tie it down and say that this Chicken McNugget came from, Larry, okay? It came from Larry, it came from Mo, it came from Curly, and about 12 other chickens. If you are looking at a cliff face and observe multiple layers of shale and limestone repeating over and over and over again, with a granitic intrusion running diagonally through it, a scientist should assume, and that should probably be a could, but what we're getting at here, obviously, is cross-cutting relationships, right? And this is arguably even a repeat question of sorts. The shale and limestone is older than the granite, okay? The argument being you can't cut through a field that isn't there, right? You can't cut through a layer of rock that isn't there. And the layer of granite is quite unlikely to grow diagonally, okay, through the air, and then get filled in around it by rock. And then the other change is that I actually use the rock name here, implying to you a type of rock which fixes the intrusive-extrusive question from before. Now, we're not going to be doing it a whole lot more because obviously we're winding down, but this goes back to what I said a handful of times and way back at the beginning of the semester. I'm never going to hold up a rock in here and say, what is this? All right, that's what lab's for. But since you've now all taken the rock test, since you are now all mineral and rock experts, it is totally fair game for me to say, you know, a hunk of granite, and you smile and nod and actually know what the hell I'm talking about. That is kind of an expectation at this point. So that's why we can say, you know, granite, and hopefully you say, oh yeah, intrusive igneous. Okay, I know what he's talking about. Let's get to the rest of the question then. So it is expected that you know, conversationally we can toss these terms around. Sure, there's a reminder here or there. There's nothing wrong with that. Okay, even if you did ace that test, that doesn't mean you retained, you know, 75% of it by now. I get that. I know that. But just a reminder. And here I already answered this question. You could safely make this assumption about the granite cutting through the rock, well, because of a lot of common sense reasons, but what we end up calling cross-cutting. Okay, cross-cutting. Now, a lot of you missed 55. And I know you know how to divide by 2. So I think we're just fundamentally missing the point here. All right? So with a half-life, every time you have one, you take half of whatever's left. And also, mixed up what parent and daughter mean, I think, as well. All right, I think some of you chose uncle and aunt and so on and so forth, which means that you just really weren't even, you know, tuned in at that point in the conversation. It might have been at the end of a lecture or something, I don't know, at the end of the day. Anywho, the simple fact is if you start with 12 and you got to get down to 3, how many times of cutting things in half do you have to do that? So half of 12 is 6, there's 1 half-life. Half of 6 is 3, there's 2 half-lives. So if you started with 12 and you're down to 3, you've gone through 2 half-lives. You don't have to know how long it takes for it to decay or break down. All of that is nice to know, but irrelevant in this point. And actually, it would be the next step. You say, okay, now that I know that it has gone through 2 half-lives, let's look up how long it takes uranium to decay. Oh, 3 days. Okay, 2 half-lives times 3 days, that's 6 days. This has been decaying for 6 days long. Now, of course, that's uranium's way longer than that, but just an example, okay? So, but yeah, I was really surprised on that one, because half-lives is something you've heard, you know, in earth science in high school, and more than likely in you know, whatever grade you heard it before. This one, yeah, these last 2, you guys, it's parent to daughter. Parent to daughter. What you start at is the parent. What you decay to is the daughter. Daughters don't make parents. Parents make daughters. So if uranium decays into lead, uranium is the parent, lead is the daughter. All right? All right. Listen here. So I tried to be as liberal isn't really the right word, forgiving as possible. If you just simply recanted something that we said in class, you know, footprints or tire tracks, I gave you a point. If you came up with actually something kind of cool and unique, I gave you 2 points. I had some pretty neat stuff that some of you read. Some of you just left it blank. Some of you just gave me a question mark. And some of you defined trace fossil. And then some of you listed some animals. So if you did stuff like that towards the end, I couldn't do a whole heck of a lot for you. But it was, as I said, a bonus question. Even though it says 1 point on there, all right, it did not count that in the thing. I got nervous when I saw that. I went back and looked. I tried making it worth 2 points, and it didn't change the total. So it is not counting that 1 point. So if you got a 0 on that question, you did not lose a point. Okay, I promise you that. I did check. But yeah, so, you know, again, any evidence. And the other thing was of unique to our period of time, and I even underlined that. And, of course, what I meant is, you know, human civilization. Some of you might have mentioned a deer, okay? And for one thing, again, a deer is a fossil, but we have had deer for millions of years, not unique to our period of time at all. Some of you tried the endangered species route, which, again, you're on the right track, because okay, I get the idea they're going to disappear from the fossil record soon. We might be like the last layer of rock that they're included in. But again, that would be a fossil, not a trace fossil. So, yes, sir, you had a question.
I think like I might have given one of my examples, but one of them was like a machine part, like a gear or something like that.
Okay, you more than likely got credit for that. Because, you know, we made, that was evidence of something making something else. So that would be a good example. Yeah. So hopefully you got at least something on that. I obviously, as I said, I didn't take points away. It was a bonus question. But depending on your level of creativity and or stress at the end of the test, you might have got 2 points out of that one. So, but if you gave me something that was right, you at least got 1 point. And remember, 1 point on a test like this with 50-ish questions is actually 2 percentage points. So that's a big boost. Okay, that's like going from an 83 to an 85, which, again, in the end, when everything is just points and math, that certainly helps. So, all right, you guys. Again, we take time to do stuff like this because we do have a cumulative final in this class, and I don't write new questions, okay? I'm only going to ask you about stuff that we've talked about already, that we've tested you on already. As I said, there are some small issues, not issues, but small things with that. I can change like largest to smallest to largest or something, you know, along those lines. But otherwise, you're not going to see any new surprise questions, at least on purpose, when it comes time for that final. So again, you're going to have lecture test 4 at the very end of the semester, the last day of class, which I think we said was the 30th, that Tuesday. Your final exam is the following Tuesday, okay? We've got like the end of the week off, I think Thursday, Friday. Friday's graduation. No, Friday they wouldn't have graduation before finals. Thursday and Friday are study days. Monday, Tuesday, Wednesday are finals days. That Friday is graduation, all right? Your final will be online, just like all your other tests. However, I probably will not be sitting here for it, okay? But test 4 will be just like all the others. I'll be sitting here. If you want to come take it, you're more than welcome to come take it in here. The other thing that people sometimes get a little stressy about is that we don't have an opportunity to review like we just did test number 4 before the final. I will do my best to get a review lab lecture cast up, okay? So you can see or hear maybe the couple that you got wrong. So we do try to give you that opportunity, but we don't have a class in between the last test and the final.